last time we spoke about functions, we spoke about built-in functions and how we use those. For example, input, which takes in something and gives us back something, eval, which takes in something and gives us back, and print, which just takes something in, as well as length. And all of those built-in functions are nice, but they're very limited in what they can do, and we kind of want to go quite a bit further if we're going to start building programs. So we are going to talk today about writing our own functions. And what functions are is they are reusable pieces of code that are not called when we write them, but they are called at a later point in time. So we're going to start with a func.py file. And I'm going to show you just a really basic function, and then we're going to keep editing that function, or we're going to keep creating versions of that function that are going to be more elaborate. So we're going to say def, which is define, which is how we create a function, how we tell Python that we're writing a function. And we're going to call this function greet. And we have an open circle bracket, a closed circle bracket, and then a colon. The same way we have if statements and for loops, and all those have colons. Our function definitions have colons as well, end with a colon as well. That just says, hey Python, this next block of code is related to what I've just done. So we take that lovely function and we add to it. We're going to add just a print statement of hi. And all our function does is it greets us. So I'm going to save that. I'm going to run my func.py file and see what happens. So right now if I run it, nothing happens. Why does nothing happen? Because writing a function doesn't run the function. It stores the function in memory, but it doesn't actually run the code inside the function. In order to run a function, we have to call it. The same way that if I want something to print, I have to actually write print over here, even though print is already loaded into Python to begin with. So with our own functions, we do the same thing. So we're going to give it 2 blank lines, and then I'm going to write greet, and I'm going to use a circle, open, close circle bracket, and now my function is actually going to run. So if I run my code again, see, it prints out hi. So now I've actually run a function. I've created a function, and I've run the function. Now, functions have a few different parts. So we have this define, this def, that's how it says, hey, this is a function. We have the name of the function. Then we have a space here. The space here is where I can put in variable names that I use, that I'm going to use within my function. And then the last thing would be, if I wanted to, and then there's the body of the function, right, which is the stuff that the function actually does. And this is usually a lot more than just one line. And then lastly is going to be, there's a return statement that I can have at the end of the function, which is the function will give me something back. So that was a lot. Let's go through this piece by piece. So this is an example of just empty. This is just an example of a basic function. If we run this, we just get the word hi. We're going to create a new function now. We're going to create a function. We're going to create a function called greet by name. So this function is going to greet the user by their name. So in order to do that, we're going to have to input the name, and we are going to have to print. And we're going to print with an f string, and we're just going to go hello, comma, space. And so what this is going to do is this is going to greet by name, which is exactly what it sounds like. Instead of just greeting the user, it's actually going to print out, instead of just greeting generic greeting, it's going to give us it's going to print out the value of this variable. Now notice here, once again, I'm declaring a function. I'm declaring there's a variable inside these circle brackets now, which means that this function requires a value in order to run. So if I wanted to run this function, what I would have to do is I'd have to go over here and I'd have to say greet by name. And then in this, I'm going to put in the name, and the name is going to be Wattle. So I'm going to save this, and I'm going to, and there's a typo in my name because my name is not recognized, but that's not important. So I'm going to run the function again, and now notice here it prints out Wattle. Notice what's actually happening. What's actually happening is here we set a variable name, and we use that variable name inside the function, but we don't assign the value until the function is called. When the function is called, we assign the value, and when there's no call, but when we create the function, we don't actually assign a value to it. We just say, hey, we're going to take that value and do the following things with it. This is obviously another, and one of the best examples of just where variables are really useful, because I don't know when this function is going to call. What's more is that I can greet multiple people by name just by reusing this code. So if I wanted to greet Ellie, then I just go, hey, greet by name Ellie, and I run my program again. It says hello Muttle, hello Ellie. And we can just keep going with this, right? And I'm reusing the same code. I just changed the variable value, the value of name, and it's greeting someone new over and over again, which is pretty cool. And that's, that's one of the nice things about functions. Now you'll notice here that this function doesn't actually give us anything back, right? All this function is doing is it's printing out whatever we want it to print out. Now what we want to do is so the next thing we're going to talk about what happens if I don't want my function to require a variable, but just it can contain a variable, right? So what happens if I want greet by name to be the only function there, but I'm going to want to make it possible to not include a name. So we have greet by name now requires a value. We're going to do something a little bit there. We're going to say greet by name equals, we're going to say name equals none. So what happens here? What happens here is now the function says, okay, by default, I have a value for this variable, but the user can override it when they call the function. And now what we're going to do is we're going to use this function to call our other function, which is getting a little bit elaborate. So if not name. Now this is where I'm using an if statement. I'm going to say greet, and that will run the greet function, else, and then we're going to print this. So what we've done here is we've gone a little bit elaborate, but we're calling one function from within another function. That's one thing we're doing. The other is here. So what happens now? If I say greet by name, and I don't put any value, right? I don't put any value in name, and I run, it just says hi. But if I do greet by name, and I put in a value of Muttle, and I run it, whoops. Yeah, same difference. It prints out hello Muttle. That was just the debug console. I'm just going to run it regular. But it just prints out hello Muttle. What's actually happening here? What's happening here is I am it's checking if name has a value. So when we talk about true false, we spoke about booleans in terms of a lot of different stuff. When it comes to, let's say, any variable name, very often instead of just having a boolean, so if you say if name, what you're actually saying is, hey, does name have a value or is it a value of none? If the value is none, then do this, otherwise do that. So I'm saying not none, so I'm saying if there's something there. It's a kind of weird backwards way of thinking about it, but I'm saying if not none, if not name. So if name is none, then greet, right? Yes. None is false. So if not none is going to be true. Then we greet. Else we do this. Else we're going to print. Just to make it a little bit easier to read this, we're going to flip it around. So if there's a name, we're going to print the name. Otherwise, we're going to just run greet. So now if I run the function, the exact same thing should happen. Right? It still prints hello Muttle, but what's happening now? So if there's a name, we greet the name. Otherwise, we just run the greet function, which greets with no name. And why does this work? Because I have the word equals none. Now, just to show you what I mean by that, if I run this function again, if I run greet by name now, it works high. If we remove the word none, and we run the function, we get back an error requires one argument. Arguments that don't have a default value are going to be required, and therefore you're going to be very careful when creating your functions. So that's the first part of functions, the input. The other part of functions is the output. And so what we're going to do here is we're going to talk about the output for our function. In this case, it is going to, instead of printing something out, we're going to return a value. So we are going to write a function that calculates the factorial of a number. Factorial of a number is just that number multiplied by all the numbers between it and 1. So define fact, and it's going to be number. The number we want to get the factorial for, and we're going to say for I in range number. And we're just going to start with output equals number. For I in range 1, number. Out times equals I. And then we go return out. Now the specifics of how this function works doesn't really matter that much. What matters more is notice here that I have this out value that I'm doing some math to, like I'm actually calculating a value for it, and then at the end of it I return out. The keyword return is the important word here. So what happens is if I run the fact function, and let's say I run factorial 5, I can say a equals fact 5, and then I can print out a. And if I print a, and I run this, I get back 120. Now what I can really do here, right, is the same way that I don't really have to do it like that. I can just run factorial of 5 directly into the print. And I can run this and I get back 120. And the nice thing is that no matter how many times if I want to get the factorial to any number now, I can really quickly just use that function to get the factorial of that number. And 54. Just out of curiosity, let's run them and see what they all come out with. So some of them are 687 is several lines long, but 2 is just 2, and the other ones are that one. The point being, though, that this is the same function that would give me back the end result. And let's say I was writing a program that for some reason I constantly need the factorial. I'd write this little function and I can just reuse it over and over again. And these are the kinds of things we do with functions. We abstract out pieces of code that we're going to need to constantly reuse. And so instead of doing them multiple times, we just call it once. Or we just write it once and then we just keep calling it using that function name. So the function in review functions have 3 parts. We have the name, not necessarily 3 parts. We have the def, that's how I know it's a function. We give the function a name, that's how I call it. We give our function some input, right? So it gets a variable, and that variable can have no default value or it can have a default value. And then we give our function, and we can give our function some output, or it doesn't necessarily have to have output. An important thing to realize here is it doesn't even need a print statement, right? I could just write a function that, adds 3 plus 5 and does nothing else with it. And that would be, a totally useless function, but it's a function that works. And it's a valid function, and the code will compile properly and it'll run. But here we just got 3 little examples of functions, all of which are focused on showing you a different part of them. And those are functions. Those are reusable pieces of code. And next video or next time we'll talk about the other kind of reusable code, or another kind of reusable code, which is classes.